Hey guys, what's up and welcome to another RMA Fire tutorial. So I'm gonna be building this scene from scratch so that you guys get an idea of how this all works. Today we're going to be testing out how we can mix liquids and apply different materials to them using the MPM solver. So let's drop down a geometry and call this our test sims and go inside, and the first thing I'm gonna do is drop down an MPM configure. What the MPM configure does is it's gonna give us a base build of what the MPM solver does, and I like to use this as a starter. All right, so what I'll do is, first off, we do not need a ground, so we're gonna select the MPM solver and disable the ground. Then this collider here, we're gonna build a totally different collider for this, and let's see. So we could do a box. All right, let me transform this box. And let's make it a size of 2. Let's go ahead and adjust the height. And I'm gonna select only the top pieces. Drop down a poly extrude. With this poly extrude, we want to do the inset, and then we want to hit Q to create another poly extrude, and we want to pull this in a bit. That way we have this sort of container. To the container, I'm going to drop down a transform because I want to kind of place it in a better place for us to work. I'm going to hit E on my viewport to scale this up a little bit, and then I'm gonna hit space 3 on my viewport so that we can put it in a really good place here. Again, I'm gonna hit space and number 1 on my keyboard so that I can come back to this shape here, and this is my collider. Now after the collider, we're gonna connect this to the MPM collider source. And if we visualize it, you can see that it's going to give us this shape. If we select voxel size, we can increase the resolution here, just like a VDV. But in this case, we're going to keep it low resolution. I'm going to go ahead and delete these two things. And I'm going to drop down another sphere. Then I'm going to transform the sphere and pull it up in space. And let's go ahead and scale it down a bit. We connect this to our MPM source, we can now select what kind of material we want it to be. And the material means like what kind of property. So in this case, we want it to be water. If we come back here, and if we go ahead and hit play, the MPM solver usually is really fast, but the first time that you enable it, it kind of runs a little slow. So that's what we get off the bat. So what we want to do is, instead of emission type 1, so we're going to do continuous, and then we're going to go ahead and play again. And now we're going to get this continuous emission of fluid. Already. Now what we want to do is create a cool sort of emission. I'm actually going to give us a little bit more space here, and we're going to just create a little rig for us. So if we duplicate this and place it here, duplicate it again, and we can place it somewhere here. Then we are gonna merge this together. And apply a transform. And then we're gonna do $F so that it's rotating. Let me see, maybe I do. We do this, we create this rotation here. Then we're gonna do actions, create reference copy so that everything that we do to it gets copied across, and then we're gonna duplicate that again. I'm hitting Alt on my keyboard and just sliding it so that I can duplicate it, and now we have these 3 pieces here, the same result. Now what we want to do is we're gonna grab this MPM source and place it here. We're gonna duplicate that and duplicate that one more time. So this is gonna give us 3 different emissions, and now what we want to do is give them a group. This is gonna be a point group, and I'm gonna make it G1, G2, G3. Now we can connect it back to our NPM solver, and I'm gonna go ahead and give them different colors. So we can make this one blue, we can make this one yellow, and we can make this one pink. Now let's see what this gives us. So off the bat, you can see how something that used to take quite a bit of time to set up before can be set up extremely fast with NPM. And now let's see, we can also go ahead and I just hit L on my keyboard so that it organizes everything. Now something cool that we can do is come here to your NPM sources, and we can play with density, and we can also play with changing this to something like honey so that it has viscosity on it. It has a much more viscous behavior that we can control here. Let's have a look to see what this is going to give us. We can see that the honey is way more viscous. And what if we make it like 0.1 in terms of the viscosity? So you can see that now is not as viscous as it was before. And then what we can do is maybe here on our second liquid, we decrease the density, so we make it pretty low. So let's see what this is going to give us. It just became a little bit unstable, but you can see that it's now, oh, the yellow is going to be overtaken by everything, and we're going to get this like really different reactions. Okay, so what do we get afterwards? So let's drop down a null. Let's see what we have here. So if we middle mouse, you'll notice that we have the color, and then we also have our 3 groups. So we can go ahead and delete them afterwards. And then we'll do group 1, and we want to make sure that it's point. And then we want to group 2, and then we want to do group 3. Select them all and do non-selected, and now we have each of them isolated as its separate thing. So we could go about it 2 ways. We could do VDV them separately, or we could keep them together and do particle fluid surface, decrease the particle separation here, And then we could transfer the color, and this is gonna give us the color that we had originally. So that looks pretty cool. We have everything that we were looking for in order to mix them. Now, how do we increase the resolution? So let's just go ahead and select the MPM container, and the particle separation is what you're gonna want to tweak. So let's make it 1.5, and I'm gonna copy this parameter, and on my particle fluid surface I'm gonna paste the relative reference here. Let's hit play and see what we get. So you start to get some pretty interesting mixing. And let's check out our particle fluid surface, and you can already see that it is already looking nicer. I'm gonna go ahead and flipbook this, and I'll be right back. Okay guys, so I'm back, and I just cached 60 frames of what we have here, and as you can see, we have some really interesting interaction. We have the liquids mixing quite well. For my taste, is a little fast, the simulation. If you guys wanted to slow it down, it's as simple as selecting your MPM solver and reducing the time scale, and that's gonna give you much slower results. But now let's have a look at how we go about like texturing it. Super quick. This is not a texturing tutorial, but I'll just give you guys a few tips. So let's just start by creating a camera, and let's find ourselves a cool spot, something like that. Let's come out and let's do an RS dome. On our dome, we want to add like any HDRI that you have. I'm just gonna do any of mine. Let's remove it from the viewport, and we are going to go into our material and do RS standard, then drop down our redshift material, and we're gonna do liquid. Okay, and now what we want to do is go into our redshift render. I'm gonna split this window on the top and bottom and make this our redshift render view. Select the camera, I'm just gonna save, and then we're gonna come in here and drop down a material. We're gonna pick the liquid material. We're gonna hit render. Okay, let me just move this up a little bit so that we can see it closer. So you will see that off the bat, we're not really gonna get any of the materials, of the colors, right? But that's because we need to come into our material and do an RS point attribute. because we want to read the point CD. Once we connect this here, we need to reload, and now we get the colors. So if we connect this into the surface and then we connect this into our base color, now we're gonna get a material with the colors that we've been playing with, right? But how do we go about like controlling them separately? So there's multiple ways of doing it. The easiest way would be for you guys to apply RGB colors before the simulation, but I've already cached it, and I'm just gonna do a little cheat here where I'm gonna apply a red, let's see, a green, and a blue tone. Okay, let's see if we do it a little bit of a different way. So let's come in here and back to where we have the color. We're gonna do actually, we can actually do color here and then select the groups that we've already created. So our group 1, and we're gonna make it red. Then we're gonna make this one green. It's gonna be group 2. And then group 3, we're gonna make that blue. We go back to our particle surface. We're gonna get our mesh with that information. Now let's go ahead and hit render again. We'll just need to remove this. And now what we want to do is RS split color splitter. This is gonna allow us to split it based on the red, green, and blue colors. So if we do an RS blend material, we're not gonna apply the colors to the materials, we're just gonna apply it here. So this would be material 1, and we're gonna duplicate it, and we're gonna do material number 2, give it a different color. Material number 3, and we're gonna give it a different color. So let's make this one green. And then you wanna connect the red here and the green here. Now once we plug this into our surface, you will see that we are now effectively recoloring stuff or re-updating the materials based off these initial colors. And you can make it metal or, you know, any kind of material that you want. So I'm just gonna just render out a cool frame, and this is still, for my standards, kind of pretty low res, but it gives you all the theory you need to know for doing cool mixing of colors with MPM. Alright guys, hope you liked it, and I'll be back with more.